In this video, we are going to take a look at some of the problems in section 746. Okay, so, section 7.2, starting with 7.46. Okay, so it says research shows that young adults who are born prematurely with very low birth weights below 1,500 grams have higher blood pressure than those born at term. The study can be found in the article Blood Pressure Responses to Physiological Stress in Young Adults with Very Low Birth Weight. The researchers found that the systolic blood pressures of young adults who were born prematurely with very low birth weights have mean 120.7 milligrams of mercury and standard deviation 13.8 millimeters of mercury. Okay, so it says identify the population and variable. So the population would be all young adults who were born prematurely with very low birth weights. Okay, and their variable would be their systolic blood pressure. Okay. All right, it says for part B, for samples of 30 young adults, all right, who were born prematurely with very low birth weights, find the mean and standard deviation of all possible sample mean systolic blood pressures. Okay, so the original variable X, right, the population has a mean of 127 or 120.7 and has a standard deviation, population standard deviation of 13.8. Okay. All right, so now in part B, they're talking about the samples of size 30, right? So that would be n equals 30. All right, and it says find the mean and standard deviation of all possible sample mean systolic blood pressures. All right, so they are talking about mu of x bar here, which we know, right, from watching the video in 7.2, that that is equal to the population mean, and so therefore that is going to be 120.7. Okay. In other words, if we took all possible samples of size 30, right, and took the sample means from every one of those possible samples and then took its mean, we would wind up with 120.7. Okay. All right. Next up, they want the standard deviation of all possible sample means, right? So that is sigma of x bar, which we know, right, is equal to the population standard deviation divided by the square root of the sample size, which is 30. And we know, well, let me just write the formula here. It's better to do it that way. So that would be 13.8, which is the population standard deviation, which they gave us in the problem, divided by the square root of 30. All right, and that comes out to be 2.52. Okay. All right, and that's it for part B. For part C, they want to know same thing, but sample sizes of size 90. All right, so n would be 90. So the sample, or the mean of all the sample means, right, would be the same as the population mean, which would be, again, 120.7, just like before. They want to know the standard deviation of all possible sample means, right? And so that would be the population standard deviation divided by the square root of the sample size. So that would be 13.8 divided by the square root of 90. All right, And so that comes out to be 1.45. All right, and that's it for this problem. All right, next problem is 748. That says, in the article Age at Menopause in Puebla, Mexico, the authors compared the age of menopause for different populations. Menopause, the last menstrual period, is a universal phenomenon among females. According to the article, the mean age of menopause, surgical or natural, in Puebla, Mexico is 44.8 years, with a standard deviation of 5.87 years. Let X bar denote the mean age of menopause for a sample of females in Puebla, Mexico. For samples of size 40, find the mean and standard deviation of X bar. That's the sample means, right? Interpret your results. Okay, so what we would need to do is to find the population mean, right? And so they say that is 44.8 years. So in this problem, mu would be 44.8. And we'll also need to know the population standard deviation. And they tell us here that is 5.87. Okay. And part A, they want to say for samples of size 40. So n equals 40. All right. Find the mean and standard deviation of X bar. So the mean of all the sample means would be the same as the population mean, which is 44.8. All right. And the standard deviation of all the sample means is going to be equal to the population standard deviation divided by the square root of n. So that is 5.87 divided by the square root of 40. So that comes out to be 5.87 divided by the square root of 40. So 0.928. All right, and that's it for part A. Part B, repeat with n equals 120. So n is 120. The population, or the mean of the sample means is going to be exactly the same as the population mean. So 44.8. The standard deviation of the sample means is going to be equal to the population standard deviation, 5.87, divided by the square root of 120. So that is 0.536. Okay, and that's it for that one. All right, and I think this is the last example. Yes, so the last example, 7.50, undergraduate binge drinking. Alcohol consumption on college and university campuses has gained attention because undergraduate students drink significantly more than young adults who are not students. That seems kind of like a blanket statement, but okay. It says, this studied binge drinking in undergraduates in the article, binge drinking in undergraduates, relationships with gender, drinking behaviors, impulsivity, and the perceived effects of alcohol. The researchers found that students who are binge drinkers drink many times a month with the span of each outing having a mean of 4.9 hours. Okay, and a standard deviation of 1.1. So that's the population mean and the population standard deviation. Okay, it says for samples of size 40, so n equals 40, right? Find the mean and standard deviation of all possible sample means. All right, so we know that that's mu of x bar, which we know is equal to the population mean, which is 4.9. And the standard deviation of all the sample means is the population standard deviation divided by the square root of the sample size. So that's going to be 1.1 and divided by the square root of 40. Okay. So 1.1 divided by the square root of 40. That's 0.174. All right, and interpret your results. That means if I took and found the every possible sample there is of size 40, right, from this population, and looked at the sample means, calculated all those out, and then took the mean of all the sample means, I would get 4.9. And if I took the standard deviation of all the sample means, I would get 0.174. Okay. All right, and then in part B, we want to repeat that with n equals 120. So I get the mean of all the sample means, again, is exactly the same, right, as the population mean, 4.9. The standard deviation of all the sample means is going to be, of size 120, is going to be the population standard deviation, right, divided by the square root of the sample size. So that is 1.1 divided by the square root of 120. So I get 0.1004. All right, and that is it for section 7.2. Okay, so in section, and you should be working these problems very similar to the problems that that we just did. And in section, what we will be doing is using section in 7.3, we will be using these means of the sample means and the standard deviation of all the sample means to be calculating probabilities similar to what we did in section 6.3. Okay, all right, but that will be the next video.